Have you ever wondered if we are living in a simulation? How would you react to the assertion that I am an invisible pink pony behind you? Can it be disputed? Science has developed a set of rules that produce the best results in the pursuit of truth. One such rule is the principle of falsifiability. Any hypothesis must have at least the potential for its refutation. The second important principle is called Occam's razor. The introduction of a new concept to explain phenomena is only justified when all possibilities for explanation, based on known facts, have been exhausted. Our world is self-sufficient, and there is no need for the hypothesis of simulation to explain its existence. Moreover, if this hypothesis cannot be disproven, its credibility is not much higher than that of me being an invisible pink pony behind your back. Have you ever pondered the meaning of life? Energy is a limited resource. By spending it, we count on a result. Whether we want to watch a TV series or explore space, actions that bring us closer to our goals are meaningful, while others are devoid of it. But can life itself be compared to a meaningful action? Creatures that do not find suitable conditions or whose genes are not sufficiently stimulated for reproductive behavior do not reproduce. Their place is taken by competitors whose genes more strongly stimulate reproduction. This process itself is independent of the will of creatures and is only a consequence of natural causes, as in bacteria, so in humans. Therefore, life is not a conscious action, but rather a natural phenomenon like wind, waves, or gravity. And since our birth is not dependent on our will or actions, there is no inherent meaning in it. But we are free to come up with it for ourselves and strive towards our set goal. Did you know that electrons in wires move slower than a snail? Electric current propagates at a speed close to the speed of light, but electrons rarely move faster than a couple of millimeters per second. But how is this possible? Electricity is not the movement of electrons, but the movement of waves between them. Look at a train. When the locomotive starts moving, it pulls the first carriage, which in turn pulls the second one, and so on to the end of the train. The entire train can move only a couple of meters, but the movement from carriage to carriage will spread almost instantaneously. The same thing happens in conductors. Electrons are densely packed, and when one starts moving, it pushes the electrons in front of it in the same direction. Thus begins a chain reaction that spreads thousands of kilometers in an instant. This wave is electricity. Meanwhile, the electrons themselves travel an average of 1 millimeter per second, which is 1.5 times slower than a snail crawls in the same time. Can black holes be other universes? Black holes are incredibly dense objects whose gravity is so strong that nothing can escape from it. Huge black holes are located in the centers of galaxies, but most black holes are not much larger than a few tens of kilometers, and some are even smaller than an atom. Can an entire universe fit into such a small volume? Gravity curves space, and the gravity of black holes curves it so much that it is sucked inward. Even light falls into a black hole along with the space through which it travels. Therefore, inside a black hole, there is much more space than it occupies. Moreover, since the process of suction is constantly ongoing, it can be assumed that from the perspective of an observer inside a black hole, it is constantly expanding. The space of our universe is also constantly expanding, and just like with a black hole, nothing can escape beyond its boundaries. In this respect, black holes and our universe are very similar. Have you ever wondered why humans don't have fur? Our distant ancestors lived in trees. During times of danger, they climbed higher. Such episodes did not last long and did not require endurance. After the transition to a terrestrial way of life, the situation changed. It is difficult to hide in the savannah, so you have to run away from danger. Prolonged running heats up the body. When the temperature reaches 40 degrees, proteins break down, and the body stops functioning normally. The advantage of walking upright is that the area of the body exposed to the wind is greater than in a horizontal position. The sebaceous glands that lubricate the fur secreted some water. When running, it evaporated and cooled the body. Therefore, those who had less fur could run longer than their peers and were less likely to become prey. This became an evolutionary advantage. By losing fur and gaining sweat glands, our bodies became like large radiators that do not overheat during long-distance running. Thus, Homo sapiens became the perfect marathon runner and sprinter. Do you know how the sun will die? Starting life, stars are composed of hydrogen, whose atoms merge under pressure to form helium. Nuclear fusion releases energy, which causes stars to shine. Hydrogen in the sun will burn for billions of years, accumulating helium in the core. This will push the hydrogen fusion higher, heating the upper layers of the solar atmosphere. As a result, the sun will expand, gradually turning into a red giant. Its boundaries will eventually reach the Earth's orbit, and the Earth will evaporate in the solar atmosphere. Once the helium core becomes massive enough, helium fusion will begin. At this moment, a strong energy burst will occur, which will blow off the solar atmosphere. The sun will become a white dwarf. In this state, it will exist for billions of years, gradually cooling down. The final stage of the sun's life will be a black dwarf, indistinguishable from a massive planet, consisting of carbon and oxygen. The sun will remain in this state until the end of time. Can Mount Everest fit in a teaspoon? Almost 100% of the atom's mass is concentrated in its nucleus, but the nucleus itself occupies only 1/1,000,000th of its volume. When a star more than 10 times as massive as the sun reaches the end of its life, its core is primarily made of iron. The fusion of iron atoms is not energetically favorable, so they do not merge but accumulate, making the core more massive. Over time, this creates such pressure within the star's core that the forces holding electrons on atomic orbitals give way to the gravitational force, causing electrons to fall onto protons and form neutrons. The size of atoms decreases by 1,000,000,000,000 times, and their nuclei, becoming neutral, merge. The falling of electrons is accompanied by a huge release of energy known as a supernova explosion, which dissipates the star's atmosphere, leaving only the core of the newly formed neutron star. The mass of 1 teaspoon of its substance is 6 billion tons, slightly more than the mass of Mount Everest.